Physical versus chemical properties and density. So properties are used to describe and classify matter. So matter just is something that defines what a substance is. Matter by definition is anything that has mass and takes up space. Now there are two types of properties that we're going to talk about today. The first is a chemical property. A chemical property is a property of a substance that can be observed when it is changing into something else as it undergoes a chemical reaction. So for example, when you see a piece of iron, it starts out as like a nice shiny metal, but then when it reacts with the oxygen of the air, the color changes and you see that like brittle orange layer that forms that we call rust. That's a chemical property of iron. Now, a chemical property can be something like that, where a metal reacts with a certain element, but it can also be when an element doesn't react with something. Like a chemical property of gold and platinum are that they don't react with oxygen, which is why we use them in jewelry making, because they don't react with oxygen. So evidence of chemical changes, the first is color change. So like we mentioned with the iron, when the color changes from that nice bright shiny metal to that brittle orange layer, that's a color change, and that's evidence of a chemical change. Also, when you have the formation of a solid or a gas from a clear solution, so all of a sudden you see bubbles forming, or your solution now has what we call a precipitate, which would be a solid in the solution, so it'll turn like a foggy color. Both of those would be considered chemical changes. Also, if you have the emission of light, that is a chemical change, or the emission or absorption of heat. Now with those, you see those a lot in first aid kits when you have like those little packets, the hot and cold packs, and you break the center and then it turns hot or cold. That's a chemical change. It's a chemical reaction within inside the pouch. Now a physical property is a property of a substance that can be measured or observed without changing it. So its state, so solid, liquid, or gas, you can take water and boil it and turn it into steam. It's still water. You can freeze it and turn it into ice. Again, it's still water. A color is also a physical property. So water has a clear color. Again, iron has that shiny silvery color. Also, the density is a physical property as well. So all of these things together can be used to identify substances. So the density is a physical property that depends on the composition of matter and the size of the sample. So the equation for density is D equals M over V. That's density equals mass divided by volume. The units will be in grams per milliliter or grams per centimeter cubed. So remember from your conversion sheet that 1 milliliter is equal to a centimeter cubed. So those are interchangeable. So those units, we can use them to compare. So why do we look at density? Well, if you look at these two blocks, it says which one has greater density. Hopefully you can tell that the one on the left has a greater density. This would be something like a metal. And then the one on the right, this would be like wood. So if you have like metal and wood that are a sample that is the same size, the metal would feel heavier because it has a greater density. The atoms are larger, they're more closely packed together. The wood, there's more space between the atoms inside the sample, so it feels lighter. So the samples are the same size, the volume is the same, but their masses are different, so their densities are different. This also can help us know if something's going to sink or float in water. So going deeper into the density equation, the first part of the density equation is mass, and that is the amount of matter an object contains. It's measured with a balance in grams, and a balance is just another word for a scale. We call it a balance in the lab, so you just put an object on it, find the weight or the mass. Volume is the amount of space something takes up, and we can measure it two ways. The first can be measured in milliliters. This tends to be done with liquids. So we pour a liquid into a graduated cylinder or a beaker, and then we can just measure the volume by looking at the scale on the side. Also, we can find the volume by measuring pieces of an object and calculating it in centimeters. Like for a block, you would do length times width times height. So we do this more with solids. So those are two ways that you can find volume for two different phases of matter. Gases are a lot more difficult to find their volume because they always take the volume of their shape. So if you know the volume, the volume of their container. So if you know the volume of the container, then you can know the volume of a gas. But it's not something that we need to calculate or worry about for tomorrow's lab. So measurement and error are the last things we're going to talk about. So a direct measurement is a measurement that is found with an instrument and no calculation. So if you take a object and you put it on a scale to find the mass, that number is the mass. That's a direct measurement. The second type of measurement is an indirect measurement, and that's a measurement that is found by calculation and the measurement. So if we look over here, if you want to find the volume of this rock, it's an irregular shaped object, so you can't find its length, width, and height because it's not uniform. So what we can do is use a method called water displacement. If I know the volume of this water, and then if I know the volume of the rock and the water, I can find the volume of the rock by taking the volume of the water and the rock, and I can subtract the volume of the water from that, and that will give me the volume of the rock by itself. That is an indirect measurement. I had to use subtraction to find the volume, so that's the indirect measurement where you need a calculation. The last thing is error, and error is the difference between the accepted value and the experimental value. So if you know that the density of water is 1, and you calculate the density of water in the lab and you find that to be 0.95, well, the error is the difference between the true value, which is 1.0 gram per milliliter, and the number that you find in the lab, which in this case, in this example, is 0.95. So that's what we would define as error. So you'll need these notes for your lab for Thursday or Friday, so make sure you have them done by then.